G'day everyone, welcome back. I just wanted to put this video together to hopefully help teach you guys how I use surf forecasting sites to plan my trips and just understand a little bit about how they work. Hopefully get you guys a little bit closer to tracking your own swells and understanding them a little bit better. When I start forecasting a swell, there's a couple of things that I check. One of them is the swell height, second is the wind, third is the period, and fourth is the swell direction, and fifth is the tide. We're going to have a quick look at each of these things, and I'll show you a couple of forecasting tools that I use. Hopefully you guys will be able to start forecasting for yourself a little bit more accurately than some of the websites out there that do it. So firstly, it's important to understand what swell is and how it's made. So swell's made from really distant, faraway storms that happen in the open ocean, and swells basically just created by really strong wind for an extended period of time. At the center of the cell where the storm's happening, you've got this like really strong band of wind that's just circulating around, and it's whipping up the seas into these massive big storm seas. So these storm seas can be 12 meters big, and they're just messy and junky and all over the place. But as those seas start radiating away from the storm cell, they start linking up into swell lines. And this is what we want. So as a general rule, when I'm looking at surf forecasting, if the center of the storm cell is close to the land, it's generally not going to have enough time for those seas to generate into swell lines, and the period by the time it hits the coast will be quite short. So ideally, there's a bit of a Goldilocks zone where the storm cell passes far enough away from the coast for then those seas to radiate out, turn into swell lines, and become a really clean, groomed swell. So I just wanted to show you a little bit about reading synoptic charts. It's not super critical to understand these things completely, but it does help to have a bit of an understanding of how they work. So let's jump into that, see if we can get our head around it. So what we have here is a synoptic chart, and these are pretty typical. You'll see them all over the place. So in the southern hemisphere, our high pressure systems rotate in an anti-clockwise direction, and our low pressure systems rotate in a clockwise direction. If you wanted to have a quick snapshot at looking at one of these things and quickly tell where the wind is going to be blowing and how strong it's going to be, you can ascertain a lot of information from these things at just a glance. So the basic rule is you can draw a line intersecting one of these isobars at an angle of 22 degrees, and for high pressure systems they're rotating anti-clockwise in an outward direction. So you can see here I've drawn an arrow intersecting at around 22 degrees pointing outward. That means that's the direction of the wind is going to be blowing. As we follow that, it's going to link into this low pressure system. So we can follow those isobars out. We've drawn a line there. So that's blowing east. That's blowing south-southeast. That's blowing south. That's south-southwest. And then up here, we're going to be having light westerlies. The other thing to consider when you're looking at synoptic charts is the closer these lines are packed together, typically that's going to mean stronger wind. The site we're going to look at explains all this, and you don't really need to read synoptic charts, but it's good to have a basic understanding of them, because if this is all you can get your hands on, you're going to be able to look at it and say, okay, I'm located in Margaret River down here, and on Friday we're going to have easterlies. Perfect. So the second thing I want to just run through quickly before we jump into the site that I use for my forecasting is understanding wave period, and this is such a critical factor when you start dealing with surf forecasting, because you have to understand how these waves move, how they increase in period, and how the volume inside each specific wave increases. So if we jump in and have a look here, I've just drawn this incredibly rough drawing, so don't hate me for that. But you can see here at the top we have a large period swell. Let's call this 16-second period. And down here we'll have a 6-second period. So you can see at the crest of each wave, that's the time measured in between two peaks. So it takes 16 seconds for this wave to pass for the next one. Our wave height is all measured here. So we'll say this is a 3 meter swell and we'll say this is a 2 meter swell. Just by looking at these two diagrams, you can see quite clearly that the volume in this wave here is far greater than the volume in this wave. So when you're dealing with a higher period swell, the amount of water in each specific swell line is going to be way bigger than a short period swell. That's why large period swells tend to be far more powerful than short period swells. The other thing to consider when you're looking at wave period is as the period increases, the speed at which that swell is travelling is also going to increase. This is important to consider when you're doing your forecasting because certain reef systems can't handle large period swells and some reef systems definitely need large period swells. So this comes back to just reading your forecast charts, having a look at the conditions, making a note of what it looks like in that day, and then just building on that slowly. The more information you remember or write down in a little notebook, it's going to just serve you in the long run to make more accurate forecasts about what's going to happen. So jumping into the site that I use for my forecasting for all my big swell trips, pretty much 90% of what I do, is the Bureau of Meteorology. And you can find that in Australia by just searching bom.gov.au. It's going to open up into this main page here. And if we navigate down to the bottom, you'll see marine and ocean. And then you'll see interactive weather maps. So as a default, it's going to open up on the total wave height. And what we're going to do, we're just going to scrub through this timeline and have a look at what's happening with swells that come through. Then we're going to repeat the process and see what's causing those swells. So you can see here in Friday, I'm located down here in Margaret River, 1.5 meter swell, which is tiny for here. Saturday, 8 o'clock, we're starting to get a little nudge up to 2 meter mark, but it's followed by a band of really small swell, 1.5. Not much to look at. 8 o'clock Sunday, we can see we're about to get a little band of swell coming through there. Monday, 11 o'clock, we've had that swell fill in to 3 meters. Tuesday, 11 o'clock, that swell's kind of passed through. We're dropping back down to 2 meter mark. Wednesday, 11 o'clock, still hovering around that 2 meter mark. Then 11 o'clock Thursday, we're back up to 2.5 meters. If I was to scrub through this timeline and pick a day that I wanted to go out and shoot, obviously I'm going to try and pick the biggest swell, which happened to be Monday. So we're going to base all our forecasting about trying to read a swell for Monday at 11 o'clock in Margaret River. So you can see here with these arrows that we're looking at, that's indicating the swell direction. So we're pretty much bang on southwest there, which is pretty good for this location. So now I've picked my day. I've identified that it's going to be 3 meters at a southwest direction. The next thing I want to look at is the wind, because if I get a 3 meter swell with a southwest direction and it's 35 knot onshore, it's not much good for shooting anything. So I'm going to navigate back up here to the total wave height and I'm going to go up to surface winds. Just be mindful, there are two wind selections here. I think it's always safe to pick the surface winds because this one tends to deal with upper atmospheric winds as well and gives you a bit of a blown out thing, so it can be a little bit misleading, but I've found surface winds to be pretty much the most accurate that we can go. So we're going to click on surface winds, refresh that view. So you can see here we're going to jump forward to Monday and we can see, based on what we just learned about our synoptic charts, we can make a safe guess that we've got a high pressure system here because we've got arrows traveling in an anti-clockwise outward direction. So that would indicate that there's a high pressure system moving in, and we can see that we've got pretty much east-southeast winds around Margaret River here, and we're looking at 15 to 20 knots. It's pretty strong, but that's workable. So I've navigated through, I've checked my swell size, I've checked my swell direction, I've checked my wind direction. All these things are good. So now we're going to move on and check our period, because if we have a 3 meter swell, southwest direction, easterly winds, offshore, it's all looking good, and then we jump in and we see our period's 5 seconds, that pretty much means that swell is going to be worthless. So I'm going to go back up to the navigation menu, drop down, have a look at wave period, refresh the view, jump forward to Monday 11 o'clock. We can see here we've had a really strong band of wave period, up to 18 seconds hitting earlier in the day. So this is at midnight the night before. So we've got an 18-second period band there, jumping through to 5 a.m. You know, we're getting 16 seconds, and through to 11, we're still getting 14-second period there. For summer, that's pretty typical, and I'd say that's going to be a nice, clean, strong groundswell. So I've gone through and checked all my parameters. I'd be confident in saying that Monday, all morning, it's going to be pumping somewhere. So then it just comes down to learning your area and knowing what your waves require. So there's waves around Margaret River that will be maxing out at 3 metres. There's other waves that won't be breaking big enough at 3 metres. There's other waves that will be perfect for 3 metres, but they like a westerly swell. So you kind of just have to get these forecast charts, figure out where it is you want to shoot, and then have a look at everything, see what it's going to do, go down the beach, take some photos, have a look at the wave. You know, does it need more west in the swell? Does it need more south in the swell? Then come back through, go through your photos when you get home, write notes about the conditions that you just shot in, and then start cataloguing them. And then over time, you're going to build this really strong catalogue and be able to just jump on these sites, have a quick look and go, yep, perfect, 3 metres, southwest direction, offshore, low tide, boom, I'm straight to spot X. You just don't waste any time driving around looking for somewhere that's going to be good. So one of the final things that I check for all my forecasting, especially dealing with big swells, is you can have these low pressure systems that build these massive storm cells out in the ocean. You have a look at your total wave height here for Monday and you'll see sick, looking big, 3 metres, but we're dealing with total wave height here. So if I switch that to a primary swell, you can see here up in the northwest of Australia we're getting 3 metres, but it's saying the direction of that swell is straight south, and even out here it's southeast. So if I switch this to a primary swell view and jump back forward to Monday, you can see the chart looks completely different. But in Margaret River here, we're still getting a really nice clean band of 3 metre southwest direction. So up here where it was saying it was 3 metres, you can see that at the actual primary swell, the swell that's going to make a coastal impact and what people are going to be surfing, it's pretty much flat. So it's important to check all of these things, because sometimes you get super excited, and I've planned trips for the right when I see these charts light up and it's 7 metres and it looks amazing, and then you switch to a primary view and there's flat. And if I had gone down on those trips, what we'd be dealing with is basically 6 metres of seas, which has got no period in it, no push, and it just basically comes and flops over the reef. Obviously this map gives you a 7-day readout. In my experience, 7 days is borderline completely useless. You'll have like 7 days out, it'll say there's a 6 metre 20-second period with clean offshore days. And then by the time it gets to 2 days out, that would have downgraded to a 2 metre onshore raining day. So I'll basically use the 7-day readout to see what's coming. And then I'll switch to a kind of 4-day readout to really fine tune what I'm looking at. And then I'll generally make a decision to do a swell run either 2 to 3 days out. Once it gets into the 3-day readout, it's generally pretty accurate. You might see a plus or minus of a metre in the swell change, and the wind direction might change a couple of degrees, but generally speaking, within that 3-day mark, you're pretty safe to make decisions. Yeah, a couple of little bonus tips. If you're out in the wild and you see a nice big halo around the sun or the moon, that generally means that you're going to be having rain within 2 days in the general vicinity of where you are. This is created from high-level cirrus clouds, which are formed of really high atmosphere clouds they're made up of tiny little ice particles. And as the light refracts through these ice particles, it creates this really nice halo. But they're super accurate to be forecasting rain. So if you do see one of them, know that you're going to get rain pretty close to where you are. It doesn't always happen exactly where you are because you're dealing with quite a large atmosphere that you're seeing. But they're super accurate. So yeah, guys, I hope you found this information useful. It's definitely helped me with so much of the trips that I do. During winter, I'm studying these charts every single day, constantly waiting for updates, and I pretty much wouldn't be able to do what I do without these charts, and this one here is pretty much the only one that I use. If anyone's found any of this confusing or you want some more information, just leave a comment below and I'll get back to everyone as soon as I can. But thanks for the support. Cheers guys, I'll see you in the next one.